This lesson focuses on absolute value functions. Now, before we continue or before we talk about absolute value functions, let's do a little bit of review. All right, so this will be a review before we begin absolute value functions. First of all, remember function notation. So function notation looks something like this. Now, remember when we graphed linear equations beginning of the semester, and you even had this last semester? So linear equation. So this is a linear equation. Y equal 2x minus 3, let's say. All right, that's a linear equation. We wrote this also in terms of functions because a linear equation is a function. If you were to graph this, linear equation using a t-table, remember what we got. If we let x be 0, and remember when we let x be 0, we're actually finding the y-intercept when you let x be 0. So when x is 0, you get 2 times 0, 0, and 0 minus 3 is a negative 3. So I'm going to plot the point 0, negative 3. So that's here. And then if I, let's say, let x be 2, I get 2 times 2 is 4, and 4 minus 3 is 1. So I'm going to plot the point 2, 1. Okay? And then we use the ruler to draw this line. All right, so that is a linear equation. It's a linear equation because the graph is a line, right? So you see it's a line. All right, so that makes this a linear equation. Now, in terms of equations, you know it's linear because besides the graph, you know it's linear because the exponents of both y and x are 1. All right. Now, this is a function. Remember a function, you can use the vertical line test when talking about a function. So for each x coordinate, there's exactly one y coordinate, right? So this is a function. So this is a function. All right. So for each x coordinate, there's only one y coordinate. For each x coordinate, there's only one y coordinate. If we continued on, let's say negative 2, 2 times a negative 2 is a negative 4, a negative 4 and a negative 3 is a negative 7. So again, one x. For this x coordinate, there's only one y value, and that's true as you continue on. So also keep in mind about the vertical line test. Okay. Now the fact that this is a function, remember we wrote this as f of x. So f of x equal 2x minus 3. Okay. And so we did a lot of things with function notation. All right. Now one of the things we did was this idea. So suppose your function is quadratic. So let's suppose I had this function, 3x squared minus 2x plus 4. All right. And with this function notation, you can ask something like this: find f of negative 2. Well, remember, f of negative 2 means that wherever you see the variable x, you're going to substitute negative 2. All right, and you had something like this on previous lessons and my math lab worksheets and tests as well. So we get 3 times negative 2 squared minus 2 times negative 2 plus 4. All right, and so using the order of operations, I'm going to square before I multiply. So negative 2 times itself is 4. 4 times 3 is 12. And then a negative 2 times a negative 2 is positive 4 and plus 4. So I get 12 plus 4 is 16, and 16 plus 4 is 20. So what I found was that f of negative 2 is 20. So those are some of the things that we did with function. Okay, so we know what a linear function looks like. So a linear equation is a function. All right, it's a function that has a shape of a line, right? Now, let's be a little bit careful. Not all linear equations are functions. Remember, a vertical line is not a function. Remember that? So a vertical line is not a function. Okay, now let's talk about absolute value. All right, the way I want to approach this is this way. All right, so an absolute value function looks like this. F of x equal something like the absolute value of x. All right, that's an absolute value function. Notice the absolute value bars. So an absolute value function contains absolute value bars. Absolute value bars. So that's your notation. Okay, so keep that in mind. The shape, though, we're going to talk about the shape. The shape's important. Okay, the shape is important. All right, so we're going to graph this, and this is the simplest kind. The one on your test, the one on your final is a little bit more involved than just one little other thing that's in there. But let's just talk about that basic absolute value function. f of x equal absolute value of x. So we're going to graph this, but to do this, we're going to use a t-table, okay? And I want you to notice something. So the absolute value of, so if x is 0, what's the absolute value of 0? Well, the absolute value of 0 is 0, right? Okay, so I'm going to put the point 0, 0. Okay? And then if x is 2, I get y equal the absolute value of 2, and the absolute value of 2 is a positive 2. So I'm going to plot the point 2, 2. If x is, let's say, 3, I'm going to take the absolute value of 3, so y equal absolute value of 3, which is a positive 3. Okay, so 3, 3. Now be careful. Don't all of a sudden, do not, I'm telling you, do not all of a sudden think, oh, okay, it's going to be a line. You're going to see what's going to happen. It is not a line, not a line. Now, so if you notice that if I continued on, it would, this for each x that's positive, it will look like it's on this, it looks like it's on the line, right? Well, let's look at this side. Let's suppose that x is -1. I get y equal the absolute value of a -1. Now remember, the absolute value measures the distance that a number is from 0. So if this is -1, what's this distance from 0? Well, that distance is +1. So the absolute value of a -1 is a +1. So the absolute value of a number, regardless of whether the number is positive or negative, is always positive. Now the absolute value of 0 is 0. All right, so I'm going to plot the point -1, 1. And I want you to notice what's going to happen. See what's happening? Get something that looks like this, right? So let's do one more. Let's do -3. The absolute value of -3, I get y equal absolute value of -3, which is a +3, right? So I'm going to put the point -3, 3. So -3, 3 is right here. And notice the absolute value function is the shape of a V. It's the shape of a V. Looks something like this. All right, shape of a V. All right, so that's the absolute value function. That is y equals absolute value of x. Notice the difference. This is a linear function. This is an absolute value function. A linear function is a line. Absolute value function is not a line. It's made up of two rays in the shape of a V. Okay? So the question's this. Is an absolute value function linear or not? All right, what are you going to say? This is what an absolute value function looks like, shape of a V. This is a linear function. Do they have the same shape? No, they don't. So an absolute value function is not linear. So it's not linear. Okay? So absolute value function is not linear. Absolute value function has the shape of a V. Has the shape of a V. Okay? All right. Now, let's look at another example. Let's graph another absolute value function. Okay, let's suppose you want to graph this. Let's suppose you want to graph y equal absolute value of x plus 2. Okay? All right, so notice that, I want you to notice something. When we graph this linear function, I just needed 2 points, all right? When I graph an absolute value function, you need to use a variety of points. 2 points is not going to suffice, all right? Because first of all, I needed to know where this point is, where the two rays meet, and that's called the vertex. It's called the vertex, where the 2 points meet. So I needed to figure out where that was, all right, and then pick some points on this side, pick some points on that side, okay? All right, so here's how you're going to do this. Now, the best thing to do is this. We're going to use a t-table, and then we're going to talk about how to find that vertex. Okay, so I would start with 0, regardless of what you see in here. I'd start with 0. If x is 0, because you're finding, remember, when you let x be 0, you're finding the y-intercept, right? Okay, so when x is 0, I get y equals the absolute value of 0 plus 2. So that's the absolute value of 2. And what's the absolute value of 2? 2, right? So I'm going to plot the point 0, 2. Okay? Now remember, we're graphing an absolute value. So what the shape? The shape is a V. Okay? Shape is a V, and that the point where the two rays meet, that's the vertex. All right, so I'm going to plot the point 0, 2. Well, that's here. All right, that's here. Okay? If x is, let's say, 1, I get y equal the absolute value of 1 plus 2, which is 3. So I'm going to plot the point 1, 3. So 1, 3 looks like it's right here. So if I look at this, it looks like if I keep going this way, that's not going to help me because I know it's going to do something like this, right? It's going to do something like this. So I need to continue on to this side. All right, so let's say 0. We already did 0. Let's say negative 1. If x is negative 1, I get y equal the absolute value of negative 1 plus 2, which is absolute value. Now, negative 1 plus 2 is 1, and the absolute value of 1 is 1. So I'm plot the point negative 1, 1. Now, notice what happened. You see how it's continuing to go down like this? All right, let's continue on. You have the time. Continue on. Let's go one more this way. Negative 2. If x is negative 2, I get y equals the absolute value of negative 2 plus 2, which is 0, which is the absolute value of 0, which is 0, right? So I'm going to plot the point negative 2, 0. Okay, so I get this. Let's continue on. Let's continue on this side. Negative 3. If x is negative 3, I get y equals the absolute value of negative 3 plus 2. Now, negative 3 plus 2 is a negative 1, and the absolute value of negative 1 is a positive 1. Now, notice what happens. See what happens? It looks something like it did this, right? I'm drawing a freehand like this, and then all of a sudden it went this way. So there's your graph. You're done. You saw what your graph looks like. So this is your vertex. Your vertex is at this point right here. Okay? Now listen carefully. Whenever you want to find the vertex, see if it's in this form, if you don't see any number in the outside, if you don't see a number in the outside, here's where you would find the vertex. You just take the opposite of this number right here. So this is a positive 2. The opposite of a positive 2 is a negative 2. You see where it is? Right here. All right, let's do another one. Let's suppose you want to graph y equal the absolute value of x minus 2. All right, minus 2. Remember what we said? Take the opposite of negative 2. Positive 2, that's negative 2, right? See where the vertex was? Right here. What's the opposite of a negative 2? Positive 2. So let's see what happens. So let's just continue doing it the same way we're doing it. If x is 0, I get y equals the absolute value of 0 minus 2, which is the absolute value of negative 2, which is a positive 2. So I'm going to plot the point 0, 2. Okay? 0, 2. Okay, so that's here. If x is, let's say, 1, I'm going to get y equal absolute value of 1 minus 2, which is the absolute value of a negative 1, which is a positive 1. So I'm going to plot the point 1, 1. Okay, so I'm getting something there. It looks like it's going to do something like this. See how remember, shape of a V, right? So think like that, shape of a V. Just like that. All right. Now keep in mind that it is also possible for there to be a reflection. So where the V is actually pointing down, but for us it's just going to be pointing up. Okay, so let's just deal with this little part in this lesson where it's pointing up. Okay. All right, let's continue on this way. Let's continue on this way. Now remember we said to find where that vertex is located, we take the opposite of this number, negative 2. The opposite of negative 2 is positive 2. Well, there's my next one right here, 2. If x is 2, I get y equal 2 minus 2, which is the absolute value of 0, which is 0, right? So 2, 0. So that's here. Let's continue on. 3. If x is 3, I get the absolute y equal the absolute value of 3 minus 2, which is the absolute value of 1, which is 1. So I get the point 3, 1. And hey, there we go, right here, right? Just like this. Okay? So there's your graph. So this is y equals absolute value of x minus 2. Absolute value. So notice the absolute value is a shape of a V. That's not linear. An absolute value is not linear. Okay? Keep that in mind. All right, let's look at another one. Let's try a couple more. Y equal absolute value of x plus 4. X plus 4. Y equals absolute value of x plus 4. Okay, Okay, so notice the opposite, take the opposite, negative 4. So think negative 4. So remember that's absolute value, so the shape is a V, and think negative, the opposite, negative 4. So you're thinking that the vertex is going to be at negative 4, right? Okay, let's look at it. So I get, let's just use 0 if x is 0. Remember that's going to be your y-intercept. That's where the graph's going to cross the y-axis when you let x equal 0. So get y equal the absolute value of 0 plus 4, which is the absolute value of 4, which is 4. So I get the point 0, 4, which is here. So that's where the graph's going to cross the y-axis. Let's look at, now, you have an inclination to go to the right because you always prefer to use positive numbers. All right, let's just go to the right. Let's use 1 then. Let's see what happens when you use 1. Y equal the absolute value of 1 plus 4, which is the absolute value of 5, which is 5. But notice what happens, 1, 5, right? So I know, see how it's pointing up like this? So I know that the vertex is going to be somewhere on this side, right? Because it's going to do something like this. All right. So then what I'm going to do, instead of going to 2 or 3 or 4, I'm going to go this way now. So let's say negative 1. Negative 1. So if x is negative 1, I get y equal the absolute value of negative 1 plus 4, which is the absolute value of 3, which is 3. So I plot the point negative 1, 3. So negative 1, 3 is here, right? I agree? All right. Let's say negative 3. Negative 3. Y equals the absolute value of negative 3 plus 4, which is the absolute value of 1, which is 1. So negative 3, 1 is here. Now remember we said negative 4, right? The opposite of this, negative 4, okay? Which is here. So let's try negative 4 now. Let's look at negative 4. When x is negative 4, I get the y equals the absolute value of negative 4 plus 4, which is the absolute value of 0, which is 0. So negative 4, 0 is here. And I think one more and we'll be done, because you notice it's going to do this. Watch. So let's do negative 5. When x is negative 5, I get y equals the absolute value of negative 5 plus 4. Negative 5 plus 4 is negative 1. The absolute value of negative 1 is a positive 1. And you see what happens? Negative 5, 1. And there you go. There's your graph. Okay? So that is y equals the absolute value of x plus 4. Okay? All right, let's do one more. Let's do the absolute value of x minus 4. Let's do that one. All right. And that's all it is. So the absolute value function is just the shape of a V, and you just got to plot enough points until you can get that vertex. And you have a ray on this side and a ray on that side. That's all you do. Okay? All right, so let's look at the last one. So this will be y equal the absolute value of x minus 4. All right, so you see the opposite, positive 4, right? So do you think, see how this was x plus 4 and the vertex was at negative 4? Do you think that x minus 4, the vertex is going to be a positive 4? It'll do something like this? What do you think? Yeah, let's try. So and we'll go ahead and graph it on the same one here. So let's see. So if x is 0, I get, remember that's y-intercept, so that's where the graph's going to cross the y-axis. If x is 0, I get y equals the absolute value of 0 minus 4. So that's the absolute value of a negative 4, which is a positive 4. So 0, 4 is here, right here. Okay? Now let's try 2. If x is 2, I get y equals the absolute value of 2 minus 4. 2 minus 4 is a negative 2. The absolute value of a negative 2 is a positive 2. So 2, 2 is here. Okay, so, oops, right here. I'm sorry, right here. So now I notice that it's doing something like this, right? So do you think that the vertex is going to be a positive 4? Yeah, it will. So let's do 4. Let's see what happens. If x is 4, I get y equals the absolute value of 4 minus 4. 4 minus 4 is 0. Absolute value is 0, 0. And then let's do, so you think it'll do this, right? You think it'll do this. So you think it's going to do this, right? Okay, let's see. Let's do 5. So if x is 5, I get y equals the absolute value of 5 minus 4. 5 minus 4 is 1. Absolute value of 1 is 1. And so we get 5, 1, which is here. And so there's the graph. All right, so this is, see this 4 right here. That's, so this one was, this was y equal absolute value of x plus 4. So notice the vertex is negative 4. This one here is y equals absolute value of x minus 4. Okay? All right, so that is how you're going to graph the absolute value function. So just make sure you understand that the graph of absolute value functions is the shape of a V. Okay, the graph of a linear function is the shape of a line. So remember, linear absolute value functions are not lines, are not linear. Okay, so keep that in mind. Absolute value functions have the shape of a V. Okay? All right, so that's how you graph absolute value functions. So that's the end of this lesson.